We're now going to look at several examples where we're using the properties of logarithms to expand each of these logarithmic expressions. Let's recall what those properties of logarithms are. We're going to be using the product rule, which says that if I have the product of two things multiplied together in the argument of a logarithm, that can be expanded into the sum of two logarithms. So we have log base a of m plus log base a of m, the sum of the two logarithms, where the first one contains the first factor of the original logarithm and the second log contains the second factor of the original logarithm. We'll also be using the quotient rule, which is log base a of m divided by n when I have a quotient in the argument of a logarithm. That's going to be the same thing as the difference of those two logs. So where the first logarithm is going to contain the value that's in the numerator or the top, and then we're going to subtract from that a logarithm containing the second value or the bottom or the denominator of that original logarithm. The third property that we're going to be employing here is the power rule, and that says that if I have log base a of m raised to some power or an exponent in the argument of the logarithm, that power, p, can be, I'm going to call it rainbowing it around. This kind of looks like a little bit of an arc or a rainbow, so I sometimes call this the rainbow rule, which is of course not an official name, but it helps me to kind of remember that the p-value can be brought around to the front as a multiplier. We do need to make mention of the fact that it comes all the way to the front of the logarithm, not the front of the argument, but all the way out front of the logarithm here as a multiplier. So these are the three properties that we're going to be using mostly. So let's start with the first expression, log base 5 of x squared times y. Now, the first thing that we have to do is deal with this as a product, because we do have an exponent, but it's not an exponent on the entire argument. It's only an exponent on the x. So we can't rainbow rule that down around to the front. We can't use the power rule just yet. The first thing that we have to do is split this up because of the product. So we'll say this is going to be log base 5 of the first factor, which is x squared, plus log base 5 of the second factor, which is y. And let me delineate here to say that we're working now in part A. Now that I have it split up into the sum of two logarithms, now we can look at this power 2 as being power on the entire argument of this first logarithm, and now we can use that power rule or the rainbow rule and bring that down around to the very front of the logarithm as a multiplier. So this is going to be 2 times the log base 5 of x plus the log base 5 of y. And I'm just going to copy paste the original down here on the left hand side so that we have a nice completed equation here. And since there's nothing else that can be done as we look through the arguments of the expanded logarithms, there's no more powers, there's no more products, and none of this can be evaluated. Like, I can't say what the value of log base 5 of x is. So this is about as expanded as we can get for this first example. So we'll say that one is done. Now let's look to this next example. We've got ln. Now remember that the ln of some value is the same thing as the log base e of that value, right? ln is shorthand for log base e. We're going to stay with the shorthand notation, but just be aware that that is log base e. Now, when we have a quotient, we're going to be dealing with that quotient first. And the reason for that is because while we do have an exponent power 2 here, that exponent is not a power on the entire argument. If it were out here, we would use the power rule first. But because it's only on the e, we're going to deal with the quotient first. So we're going to say, expanding it due to the quotient, the ln, which is the same thing as log base e, of the top, we are going to subtract top minus bottom here. ln at the top minus the ln of the bottom. And now that we have it expanded like this, we can go ahead and use that power rule to bring that power 2 down around to the front as a multiplier. So we have 2 times the ln of e minus the ln of 7. And we're going to look at the logarithms that we now have to see, is there anything else that we can do? Let's take a close look at the ln of e. Remember, the ln of e is the same thing as the log base e of e. And the log base e of e is going to be equal to the exponent that goes on e in order to bring me back to the argument of e. So e raised to the first power is e, and that means that the ln of e is therefore going to have a value of 1. This is a very common logarithm that we evaluate, so it would benefit us to be able to recognize that the ln of e is 1 without having to calculate that every time. So this is going to be 2 times 1. The ln of e has a value of 1, and then we're going to minus the ln of 7, which is a decimal quantity if we were to put that in our calculator, so we're going to leave it as ln 7, which is an exact value. So 2 times 1 is just 2. We're subtracting the ln of 7, and this is our final answer, completely expanded and evaluated as much as possible. So here we have an example with a lot going on. We've got a product of two things in the top of the fraction. We've got a quotient, and we've got a power. And so the power rule cannot be yet applied because this power 3 is not a power on the entire argument. So we can't use the power rule first. And when we have products and quotients, really the first thing that we want to deal with is the quotient. We want to level this fraction where we are going to consider the top minus the bottom. That's our first move, basically. So we're going to expand this first using the quotient rule, where we have the log of the top, which is 100 times x, and then from that we're going to subtract the log of the bottom, which is y cubed. Now, let's make mention of the fact that this is log with no written base, which means that the implied base is 10. Of course, the shorthand would be to leave off the base, but there is a base of 10. It's just not a written base. Now, we're going to look into each of these individual logarithms to see what else I can do. Here I have a product in the first one, so I can split this up using the product rule, and now I can rainbow rule or use the power rule on this second logarithm, because now cubed, or the third power, is a power on the entire argument. So let's expand these two. So our first expansion is going to be dealing with this product. So we'll say the log base 10, but we're not going to write the base, of the first factor, which is 100, and then to that we're going to add the log base 10 of the second factor, which is x. So we've expanded the first logarithm based on the product rule, and now we're going to subtract. This power rule is going to be applied to the second logarithm, where I'm going to bring the 3 power down around to the front of just that logarithm as a multiplier, and we'll have 3 times the log base 10, but we don't write the base, of y. And we're almost done here, except for the fact that this logarithm can be evaluated. So let's just make mention of the fact that this is the same thing as log base 10 of 100. And log base 10 of 100 is going to have a value of 2, because 10 raised to the 2 power is equal to 100. So we'll evaluate this logarithm and call that 2 plus the log base 10 of x minus 3 times the log base 10 of y. And this is our completely expanded and evaluated logarithm. We started off with the log base 10 of 100 times x over y cubed, and this was what it expanded into being. Our last example in this video is log base 2 of p squared times r divided by 8 times the square root of z. And we're now going to expand this. The first thing that I want to do before we start expanding is to rewrite the square root of z as being z raised to the 1/2 power. We like it we like these radicals to be expressed as powers because of the fact that we have a power rule that we're going to apply. And it's easier to apply that power rule if we're looking at radicals as powers. So let's go ahead and say, for starters, that the log base 2 of p squared times r over 8 times, just rewriting z to the 1/2 power here. Now, again, the first thing that we want to deal with is the quotient, and we're going to deal with that quotient by using the quotient rule. And remember that we start by subtracting those two logarithms in the direction of top minus bottom. So we end up with the log base 2 of the top, or the numerator, is going to be p squared times r, and then from that we're going to subtract the log base 2 of the bottom, which is 8 times z to the 1/2 power. Now we'll say we can use the product rule on each of these because each of these have products. We're not allowed to use the power rule just yet because neither of those powers are powers on the entire argument. So let's start with the product rule. We'll expand this first one as a product. So this is going to be the log base 2 of p squared plus the log base 2 of r minus, now this second logarithm is going to expand into a sum, but we're subtracting that entire second logarithm and whatever it expands into. So we do need to open up parens to encapsulate that expansion. And so we'll say this is going to be the log base 2 of the first factor, which is 8. And since it's a product, we're going to say plus the log base 2 of the second factor, which is z to the 1/2 power. So now we keep going, and we're going to take this power 2. We are able to use the power rule now on this factor and this factor out here. So we're going to pull that 1/2 down around to the front of just its logarithm. We'll also in this step distribute the negative into this parenthesis as well. So we're going to have 2 times the log base 2 of p, because that power 2 was rainbowed around to the front as a multiplier, plus log base 2 of r. Now, distributing in the negative, we have minus the log base 2 of 8. Distributing in the negative and rainbow ruling that 1/2 down, we're going to have minus 1/2 log base 2 of z. And everything has been expanded. We no longer have any powers, products, or quotients in the argument, but we do have one of these logarithms that can be evaluated. Let's notice here that the log base 2 of 8 has a value of 3 because 2 cubed is equal to 8. So let's evaluate this, calling it 3. So because this 3 occurs in the middle of this expression, I'm actually going to move it to the front so that it doesn't accidentally get tangled up in the argument of these other logarithms. So writing that negative 3 at the front, and then I'm going to have plus 2 times the log base 2 of p plus the log base 2 of r minus 1/2 times the log base 2 of z, and this is our final expansion. Nothing else can be evaluated or expanded for that logarithmic expression.